Welcome to part 2 of the video for day 15. In part 1 we introduced the concept of indefinite integral. Let's now try to solve more examples. Let's try to find more integrals. Here we have the integral of 1 over x dx. We want to integrate 1 over x. And by definition, we define the indefinite integral as any primitive of this function plus c. And in this case, this integral is usually written as like this. We put the dx here in the numerator over x. And now, we need to find a function whose derivative is 1 over x. That is, we want to find a primitive of this function. And we know that the function natural log of x is such that its derivative is 1 over x. So this function is a primitive of 1 over x. That means that this integral equals the natural log of x plus c. And you see that to solve integrals you only need to know derivatives in the beginning. Then we're going to learn more techniques for finding more complex integrals. So at this point we can begin to build a short table of integrals. A table of integrals is a list of integrals with their formulas. And I provide you with a very short table of integrals in the guide, in the short guide for this lesson. You'll find a short table of integrals, and you'll be able to use it to find other integrals. As an example of a formula that is in this table, let's check one of them. One of the formulas is the integral of e to the x dx. We know that if you take the function that equals e to the x, its derivative is e to the x again. So the primitive of this function, a primitive of this function, is the same function. So we had that this integral equals e to the x plus c. And as an exercise, you may check the formulas in the table of integrals. To check any formula, you only need to take the derivative on the right side, and you should get, when you do that, you should get the function you're integrating. So that's how you can check, even when you're solving any problem on integrals, you can check your answer by taking the derivative. Let's talk about some little properties of integrals. These properties come from the properties, the analogous properties of derivatives. And well, the first one is that if you take the integral of f prime of x, that is the derivative of a function, by definition you get the function f of x plus c, because here we put a primitive of this function. A primitive is a function whose derivative is this function that you're integrating. So that's f of x. This is just the definition of indefinite integral. Another property is the property for sums. It says that if you take the integral of the sum of two functions, that will equal the sum of the integrals of each of the terms. And this comes from the analogous property for derivatives. And also you can, if you are integrating a function times a constant c, you can take the constant out of the integral sign and take the derivative of what is left inside. This also comes from the analogous property from derivatives. And okay, in the following videos we're going to learn more techniques for finding integrals, and we'll get to use all these properties and you'll get very used to these properties. So that's all for now. Thank you for watching and see you next time.